First of all, thank everybody who is here, despite the technology issues, and I believe this will be a fantastic learning experience for all of you. I want to say upfront that this is not an in-depth session, this is an introductory session. Those who are feeling a bit overwhelmed, you don't have to worry, we're going to be covering a little bit depth. And I also understand this is a .NET user group. I've been in this group for a very long time, so I know a lot of people around here are extreme .NET programmers. So what that means is they are exceptionally good at what they do. So you will not be disappointed either. We will cover some code. So I said this is a broad topic, and I've attempted to cover a broader segment of publishing, and hopefully you'll learn. There is also going to be hands-on sessions for those who have brought their laptops, and we have suggested that you install Docker and some additional software after about 115 slides, which will cover the introductory discussions. Okay, with that we started, right? AI, that's on top of mind for everybody, right? So what we're going to be covering is more about AI, and the workshop session will be more about data collection, and specifically working with the microcontroller and how to use that, right? That's kind of what we're going to do. Does anybody know the story of those 4 blind men who tried to explain an elephant? That's the situation with the world of AI right now. Those who do not know, 4 blind men tried to explain an elephant. Everybody ended up with 4 different parts of it. One guy who ended up with the leg said the elephant looks like a pole or a pillar. And the other guy who said elephant looks like a snake, right? This is how they ended up with the tail. Everybody who has their own vision of how they are viewing AI, they are trying to define it their way, right? So that's that story means, but I'll let you guys research about the story. Let's get to what we're going to cover today. We'll talk about AI agents. There would be confusion over what is AI and what is AI agents. We'll cover that as well. We'll talk about data collection. It could be anything from collecting data on a spreadsheet to using sensors. We'll also cover the ethical considerations. This is a big topic of discussion when you're talking about anything to AI. What are the ethical considerations or concerns that people have about collection of data? Tools and technologies, tools and techniques that people are adopting. Then we'll do the workshop with them. With that, let's talk about how did we get here, right? A little history about AI. It all started about 10 plus years with, I think it's all started in Google's DeepMind lab or wherever, right? That's probably where it all started. The whole concept about artificial neural network. Artificial neural network is nothing but trying to understand how the human neurons function and try to mimic that functionality. And they try to replicate that kind of a mechanism in software. That's where it all started. It comes under the first step of the machine learning algorithms. Then came the whole idea about computer vision. That's next level of development is called convoluted neural network, which it basically means that it helps you do vision-based analysis. Today, anything to do with camera-based detection processes, trying to understand people who are violating on their traffic violations. We are able to use cameras to detect it. All of those things are a part of convoluted neural network-based or CNN-based computer vision-based. Right? Then came the natural language processing. This is about the next step of evolution, trying to understand human speech. It started with purely understanding textual language, understanding the intricacies of it. Started with obviously English, and then it's moved on to other languages. Then came the explosion of this generative with the ChatGPT coming into existence. Everybody became expert in AI because now everybody can log in, create an account in ChatGPT and create prompts. So ChatGPT, for those who do not know it, is nothing but another implementation of a technology called transformers. So you are basically able to predict the next word. That's what it is. That's all it does, right? The basic concept of that underlying principle of this is trying to predict the next word. Now what happens when you try to predict the first word, the next word, the next word, and finally you are able to generate full text. And then a lot of other things can be tagged upon. Today, we are able to generate code, we are able to generate whatever, right? A lot of different ways. So the ultimate goal of this whole thing is to get to AGI. You may have heard this word, average general intelligence. So what this means is to be able to think and act like human, like not act, maybe at least think like human. So that's the nirvana state. Nobody has been able to accomplish it, or nobody has said that they have been able to accomplish it yet. So it is the continuum. All right, with that, let's talk about AI. Because we're going to be talking specifically around AI agents, right? So with that, the history is out of the way. We're talking about AI agents. What is AI agents? This is the classic definition that I could find from what Amazon has tried to explain here. The core point of this thing is, what does it do? AI agent will try to collect some data, right? But the goal of this AI agent is defined, self-predetermined goal. But how to accomplish that goal is handled by the AI agent. Right? That's the very basic definition of what AI agents could be doing, right? So let's start with this, right? There is a lot of variations in this thing. Every vendor, every provider is trying to define it in their own way. But fundamentally, as a general concept, it is, there is a goal, and the agent is able to do certain things. Let's talk about different types of agents. Different types of agents could be as simple as reflex-based agents. What it means is you define a rule. Right? Do certain things, move 10 steps and turn left. That's a rule. You define rules like this in your agent, and then the agent will perform those rules. That's the simple reflex-based agent. That's simplistic in nature. You go to this website and download this file. Agent can do that, but that's the simplest one. On the other side of the spectrum is about the learning agents. Okay, you go to this place and download this, but I don't know if there is something there or not. So then what should I do next? The agent will try to learn from a mistake, an error, and try to do. That's the other side of the spectrum, right? So in between there is a model-based reflex, then the goal-based. These are all different classification of different types of agents. Okay? All right. Another common, gives me a few seconds to load. The common discussion is about RPA, or robotic process automation. This is a hot contested topic about what is RPA versus what is an AI agent. RPA is closest to the first one that we saw, a rule-based approach. So it's saying data entry. So imagine companies who are receiving invoices and you're trying to use a bot to read these documents, and it's just very specific rules that you have coded into the program. It just repeats that very efficiently, does the same thing according to the rules of the program. So that's the basics of robotic process automation. There are some tools like UiPath and a few others, and all it does is you teach the program, click on this button, then click on this button, do this. So you rule define is these rules, and then turn that into a bot. That's a robotic process automation. AI agent, on the other hand, is supposed to be adaptive. So let's say in many of the bots we implement with it, and what happens is, okay, now the program version has changed. The position of the text box, instead of this place, it's somewhere else. And the button is somewhere else. But the process flow is still the same for, let's say, creating a customer, right? Creating a customer for text boxes and a button, right? The process is still the same, but the position has changed. The bot will fail because it is looking for that position of that location, right? The AI agent, on the other side, is more adaptive to understand. You define what are the things they're looking for. It will try to adapt and to do a little bit more intelligently and try to learn from the next time onwards. The key point over there is the decision-making capability is built into that agent, right? That's fundamental. I might be using the AI agent and agentic AI simultaneously, but bottom line is I don't get hung up on the terminologies, but more around what is it actually doing for us, right? That's what I'm trying to explain here. The closest example is like chatbots, self-driving cars. We define start and destination, the cars that are supposed to navigate through neural maps that is using. But what happens if there is an obstruction, the construction scenario that's happening on the road? It will learn and adapt according to that scenario. That's what the AI agents are supposed to do. Generally, any of this self-driving and all those environments, they would use this kind of an approach. Moving on to data collection. This whole discussion is not just about agents. We are talking about data collection process. Obviously, for any AI to function, it needs data. It's not just the volume of data, the right amount of data, the quality of data, right? A lot of things about the data that is very important for this things to function. How do you do this, right? Typically, what are the common strategies? So, a lot of information is available on the web, right? Web scraping is a very common use case. Everybody wants to understand who are my best customers, where do I find it? What is my competition talking about? You can use these kind of simple strategies, simple web scraping technology to understand a lot more about which customers are my competition targeting. There are many different ways in which you can use web scraping as a tool to utilize it for your business. Sensor data integration. Everybody, when we're talking about sensors, it's not just the human beings that are providing the content. You are collecting the information from ambient noise, ambient sounds, different lot of sensors are able to offer this kind of insight. At the same time, we're also offering this human in the loop, right? Things like crowdsourcing. Imagine if you are able to tap into your phone and collect this data every time you are reaching certain area that everybody's phone are able to detect that there's pothole there. Then now imagine the impact of having enough data to understand the civic services that can be offered by understanding what might be happening in the environment. This is an extreme example. What I'm explaining is that the sensors can be utilized in so many different ways without the human intervention that increases the capability of what an AI agent is expected to do. All right. We're talking about Internet of Things. So anytime we talk about sensor, the common discussion comes around this. IoT is covered around the Internet of Things. Everything that you can see around can be turned into talking to an internet. So what is that? IoT, right? The key point over there is IoT has shifted away from this collection of data and then process it into more of an edge device. The microcontrollers that you will be working today, they are computing device. It has the capability to run small computing capacity. So instead of traditionally, you would collect this information, send it somewhere, and then the message comes, you've got to do it. Now, people are talking about at the edge level. You collect it, apply the model is going to tell you what I should do about this, and do some level of processing right there. So that's the whole concept of edge computing, or rather, you can keep the computing as close as possible to the edge where you're collecting the data. Right? With that, we'll talk about the next two things, which is another important aspect of this about what is learning. End of the day, this AI systems has to understand the environment, learn more about it. There are two common techniques that people use. One is supervised learning. Supervised learning is you have human beings advising or supporting that learning process of the software or the system. The other one is unsupervised, which means you send it data and let it figure out how the data is looking. Effectively, the way it actually does this by utilizing some of these common algorithms. The most common algorithm for a supervised learning is linear regression. It's very basic, but it still works. It's probably the most commonly used all over the world. It's just a very simple mathematician we're talking about. If you have anything to do with AI, it's best that you at least learn what these terms mean. It's best that you know about what is linear regression, k-means clustering. Even if it is not meant, even if it is meant for your interview preparation, but at least learn what of these terminologies means, because you would be using some of it at least in anything to do with your lives. So with that, let's talk about ethical considerations. Typically, there are four major considerations: privacy, data security, bias, and legal. At this time, I would like you to raise your hands. Look at these four options and you tell me which one. Okay, let's start with one, privacy and consent. How many of you believe that privacy and consent should be the number one concern for data collection? 1, 2, 3, 4, 5, 6, 7, 8. Okay, perfect. What about bias in data? 1, okay. Data security. 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Okay. So, I think the majority is between data security and privacy and consent, right? So this is it. The first attempt was to make sure that you're not asleep yet. So second was the same time, make sure that get a sense of what is people talking about. People are concerned about these two things, which is data security and privacy and consent. How people going to use my data? This whole discussion around TikTok. What is TikTok going to do with my data, right? And some of them sound scary, some of them is overinflated. Either way, the point is people are concerned about these two aspects, right? So challenges in data collection. What are the common challenges here? The typical challenge are quality, anything ranging from 8 to all these 6 concerns. For the mass majority of people around here working in technology, I would expect the top 3 would be your primary concern, right? Your quality of data, your integration capabilities, that might be compatibility, and how am I going to store this data, and how long am I going to store this data. But the others are all important, but if it's not the other way, I would love to hear after that. Okay, tools and techniques. Anytime you're talking about building AI agents, some of these tools will come in multiple places in your research. But the question is, since this is mostly .NET and Microsoft, this is what is coming from Microsoft, but the whole point is this is not started with Microsoft. This has started with the rest of the ecosystem that exists around it, right? So it started with, probably the Lang is the oldest one. The others are all in different stages. So there is other tools, of course. More mature will be that, but the other tools like Rasa, Flow, these are all very respected tools. Rasa is actually open source, and we'll talk more about it later as well. But because this is .NET Group, we will be focused more on the other ones. We'll talk a little bit about LangChain, but the other ones. But I want to give you a view of these common tools if you're thinking about building anything around this. So you absolutely need to know what these tools are, so you can intelligently make a recommendation for yourself or building for yourself. So let's talk about the first one. This is semantic kernel. I explained earlier that Microsoft started a little late, but it has caught up quite a bit. We'll talk about that. The closest one we have is the semantic kernel. If you've not heard this term, those who are in .NET and Microsoft who are searching for stuff, you may have run into this semantic kernel. This section, the bottom section, explains the different stages of it, starting from it, getting the packages. What packages do you need? These are the .NET packages: semantic kernel, exception pack, extension logging. This is more for telemetry purposes and stuff. But in any case, you do need semantic kernel as a dependency, and depending upon what else you use, you may need additional dependencies. The bottom continuum of the stuff 1 through 8 and 1 through 10 is what you're going to need if you're building anything credible or usable. Right? As of now, Microsoft suggests we use the semantic kernel if you are trying to build anything with this, because the point, also note that it's not just C# anymore. It has C#, Python, and Java. This used to be health a couple of years ago. If you put anything around Java in .NET space, people will boo at you. So now people have to the idea that this is not just .NET anymore. You have to live in an ecosystem. The basic concept is, if you are interacting with OpenAI, you're going to need an API key. It's very simple. Go to openai.com, request an API key, check through the sites, and you'll figure out how to get an API. You do need that API key to be able to talk to that endpoint. Second part is about enabling what planning should I do, and basically means that when you go to ChatGPT and establish the prompt, one important thing to notice is a concept called temperature. So for anything to do with code generation, anything more the agentic or agent related, you want the minimum hallucination possible, which means that there's a minimum amount of creativity. It means you're trying to put temperature 0, right? That's what I'm talking about. So last part is about how to deal with endpoint, and it will give you the OpenAI's endpoint, and it will be the response that you're looking for. Interesting thing to note is that it also has a history component, which means it will be able to read from whatever you provide as a history, and it will use it as a context too. Let's talk a little bit about LangGraph and LangSmith. I have to say this because this is the most commonly utilized product right now. The important thing to note is that part of it is open source, part of it is not open source. That is what the right side chart explains. The LangChain and LangGraph has open source. So LangChain is something that will help you create a system of an agent. So it's a simple things like, okay, till this point is about which model am I using. This is agent. You're defining what that agent should look like and what the agent is expected to do. Right? That's the second one. So you would create the environment which model is supposed to use. This is unfortunately Python code, but don't worry, we will go to .NET in a bit. Effectively, the simplest form of what LangChain is supposed to do. LangChain is a lot more efficient with proper tooling to do a lot more complicated things. You have multiple agents to be able to chat with each other and perform a certain activity. We'll go through an example there. With that, let's talk about Autogen. The bit of history about Autogen is that it started with Microsoft. I think he's family known as Song Chi. After he started Autogen 0.2 version, He decided he doesn't want to work in Microsoft anymore, and he got offered into work in Google. Microsoft said they can't have it, and he wanted to open source it. Microsoft decided to keep it. So he decided to fork into AC2. Now you will see which is a fork version of what he initially had, and they are both going in two different parallel paths. Microsoft is adding some additional features to Autogen capability. Now it's 0.04. It's still not production ready, but it is almost there. It has almost all the features that you would expect from your LangChain's ecosystem, and it is able to do a lot more. So the question really is, what does it actually do, right? What can you do? Think of it as the simplest form. Imagine you're asking GPT to write a story. And I'm assuming everybody has done it. If you have not done it, go home and try it. Go to ChatGPT, ask, write me a story. But that's not enough. If you're talking about anything that is practical or usable, you do need checks and balances. You need one person, traditionally everybody, this is how you think about any application development, right? Anything that you're making users or dealing with money or whatever, you need verify that it meets certain standards. So what do? You ask the ChatGPT to write a story at whatever the LLM that you're using to write a story. Then you need a separate LLM or an agent to verify that these stories are meeting certain standards. There's no profanity in there, whatever is appropriate for a kid's story. Then that's the simplest way to understand this, right? You have an agent that does this, then a second agent that does something else. Now you can chain all these agents together to do a series of things, right? Okay, today you have different roles, right? People who are recruiters, people who are doing development, people who are sales, people who are doing different activities. They all will have different processes and stages. Right? So you would want checks, you want different agents to different things. So that's what it is. But that's the simplest form of the agent 1 and agent 2 doing, okay, one does something, the other one checks. And then you define how many times you want them to go back and forth. Okay, you write a story. It verifies against it. It did not meet the standards. Ask them to write again. You write again the standards. Then you define how many times do you want to go. So if you define 3 times, after that, okay, I can't do it anymore, forget it. But that's also possible to embed into that process. This is managing all of these stages and processes. So here, it would be conversational agents. You, an agent A, will initiate a process. Agent B will perform something. And then agent C may be managing the process. You can think about variations of systems and processes to make sure that these agents are behaving within the constraints of what it's supposed to do, and it is able to accomplish the task, right? So now we have a management mechanism. Now the obvious question comes, where does it become an API and where does it become an agent, right? API is basically means that you can call an API and it will give you certain functions, certain things. The agent can do multiple processes and multiple stages, and they need not be sequential. It can be managed by a centralized process and stuff like that. So you have flexible multi-agent conversations. What does that mean? You may have an agent in one company, an agent in another company, and they are talking to each other, negotiating prices. We have already seen recently that the AI was able to recreate itself. Very recently we saw that it's able to duplicate. It sounds scary, but this is where it's going, right? Bottom line is, today, what has happened? 2 salespeople on 2 sides of the 2 companies, they negotiate prices. And before their product, whatever they are selling, the other guy is buying, the other way around. The recruiter and the candidate is negotiating on prices. So now, imagine the recruiter hands off to a chat agent and asks these guys to negotiate the price. I'm just speaking a theoretical example, but possibly it may not even work out. Bottom line is, this is almost here. Right? This is where we are going. Let's talk about a little bit of code, very code focused. Okay, for those who are code focused, right, and if you're talking about Autogen, I said that Autogen is not just Python, and even though majority of it is written in Python, Microsoft has come up with the .NET version of it. The code that you see here is an example of Autogen.NET code will look like. So like I explained earlier, there's 4 stages, 4 steps. First, this is a simple example. A teacher, you have 2 agents, a teacher and a student. A teacher is telling a student agent to giving him a math problem, and the student agent is trying to solve that math problem. Very simplistic problem. So what does it do? You define, this is how your system message looks like. You create an OpenAI chat agent and define what model do I want to use. This is ChatGPT 4 mini. This is the cheapest one, maybe, but it keeps changing every day. You can absolutely use Olama or any other, whatever the DeepSeek for that matter, doesn't matter. Whatever model you use doesn't matter for these kind of agents. Use that and define what your system role is. Your name of the agent is a teacher, and you say, you are a teacher that creates preschool math questions and check the answers. You define what the parameter of the skill of this agent is supposed to be. Then you say, if the answer is correct, stop. Then the process stops. The student, you're saying you are a student and you're supposed to answer a question from the teacher. Very simple approach. So this, you define the teacher agent, you define the student agent. Then you need to initiate the conversation. That is the number 3 portion. Start the conversation. The process is initiate, you'll say, hey teacher, please create a math question for me. That's the initiation process. And after that, this kind of gives you the output of what this process, when it runs, it'll going to say, of course, here's the math question, what is 2 plus 3? This is from the student, something happens, the sum of 3 and 4 is 5, and then the rest of it is, if it is correct, it's a complete. Then you show the whole thing, but you get a picture of what practical purposes this is what we are talking about. Right? You can have 2 different agents performing a predefined set of activities, and you are able to see how these agents are performing. You're able to understand it, you're able to interfere with it. Let's say the teacher gives a calculus problem to a 4th grader. Obviously, that's not going to be the right approach, right? So you could build an agent to match those human-in-the-loop scenarios. All right. This is for those who are code inclined and willing to write code. Max rounds. So we said earlier that we can say, how many times do I want to go back and forth? That's defined by that max rounds. So you say, give a question, the teacher and the student answers. Maximum it can go up to 10 times, so back and forth. This kind of explains in the context of how any of these agents operate. We'll say, what is the role? What is the prompt it's supposed to use? What skills this agent is supposed to have? How many times am I supposed to go? And is there a human involved? At what stage do you involve a human? Right? That's the rough idea of what this is supposed to be. All right, there we go. So those who do not want to play with the code, luckily there is another option, which is the low-code option, which is also Autogen Studio. I only use Autogen as an example because that is most friendly to the .NET people, but you have the same exact tools for other platforms that we discussed as well. The simplest one gives you a UI. You can say, which agents do I want, and what are the skills each of these agents should have. So Autogen is a low-code interface which will create an agent for you, and you can run that agent once it's created. You create that results in a JSON file, publish it, and then your agent is live. So that democratizes your ability for you to write agents, right? And more importantly, it is starting to revolutionize what a business analyst will think about. Right? You are thinking about a banking process. A business analyst start putting together this step-by-step processes, and then you can do these things using a low-code interface. Turn around and you can turn into a code as well, right? Of course, you need somebody to verify that one more time, but we are at the point where these things can be done by those who has never done code before, right? The right side is a bit scary example that explains why. Imagine there are 2 different agents. Use the proxy agent, and the other one is called assistant agent. The first agent is telling you, plot a chart between Tesla and Meta, right? These 2 stocks. Now, the next step is saying the assistant agent is giving you execute the following code. Now it has generated the code. When you are doing that, the next part, see, error package Y-Finance is not installed. You see the code, but the Y-Finance package was not installed. Now it's actually saying, sorry, please first install Y-install. The agent generated the code, interpreted what was wrong, and even told him the next step to install that code. That sounds scary, doesn't it? Especially when people said earlier about security. This opens up a whole bunch of other problems with security. Where does it end? You generate code, you executed code, and then it even installed what it's supposed to do. It got the output. It got the final one, okay, installing, and then finally it got the output of what it wanted. Now there's a few more steps saying, I didn't like this output, change it this way, so it changed the format of the output. And this gives you a feel of where things are going. Even with Autogen Studio, you are able to accomplish a lot with this. With that, I want to leave you guys with finally starting to work. What does it all mean, right? So far we have gone through, those who have been in this software for long enough, you have seen a lot of test-driven development, agile development, a lot of these terminologies. Now, we are entering an era where people are talking about conversation-driven development. I did not make up this term. This was originally coined by the open source tool. They created, I can see that this is starting to take root. We are talking about a stage where development is not test-driven anymore. What it means is you might even create the test cases that you want and it will build it for you, right? So it is starting to evolve into the next stage of thinking about conversation development. So this probably would make sense for some of you, right? The point is, it is about trying to listening to your users and improve along with it. This is the nirvana people have been promised for a very long time, but never been able to accomplish. But I think we are getting one step closer and closer to reaching a place where it might make a lot of sense. All right, with that, I would like to pause and answer any questions. I know I told a lot of stuff and part of it may not make sense for a lot of you, but this is a great time. I'll pause here for a few minutes to answer anything that did not make sense, or if you have other ideas that you want to talk about, anything that you have heard before that it does not make sense, this is a great time to talk about a few things. Yes?
So multiple agents can be used together to create like a functioning and managing a firm, right? Something like that?
Mm-hmm. Yeah. That's a realistic possibility. It depends upon how complicated you want to make it and where you want to go.
Your code examples and all of the APIs looked like it was single agent to single agent. Are there patterns or architectures that support developing, let's say, 3 agents or 4 agents and letting them loose in a room to decide how they want to hash things out on their own?
Absolutely. That's the whole purpose of these multi-agent conversation and hierarchical chat. This will only become practical only if you have multiple agents with multiple skills and a management infrastructure to manage them, understanding the telemetry to understand what's happening. Right? Otherwise, it will not be functional. So yes, absolutely.
Gotcha. Oh, yeah. So there'd either be an orchestrator managing a hierarchical chat, or there'd be a joint chat model would just be n number of agents hashing it out. Cool.
That's exactly what it's called. An orchestrator would be able to orchestrate. There are, going to any of these things in deep, I understand it would be too deep. If you have questions, please do. I would love to answer. Yes.
Just to be clear, the basic fundamental, every agent needs an interface to a large language model or an AI.
Not necessarily. An AI agent could be as simple as an API call. This agent is proficient in getting stock prices from, taking an example. So that does not have to be an AI agent, right? It could be a bot that gets somewhere. Again, like I said, there is no cut and dry definition of what is an agent. People are starting to define in their own way. But in my point, can you argue that this is in the same way as service-oriented architecture years ago we promised that everything will be an API-based call? Maybe, maybe not. But does it answer your question, sir?
In none of the discussions have I ever heard anybody talking about their agents having a value system. And I know there's discussions about bias, but in my opinion, that every decision is biased based on whatever everybody thinks a piece of information. Now, in complex abstract systems, say you're running a city, okay, what's important today may not be the same as what's important tomorrow.
Correct.
Values change. The overall situation is changing. How do these systems handle that or do they?
Let me ask you in the similar way. In a physical world, let's talk about the same city. How do you handle it today? What's our current mechanism?
Different people handle it differently.
Of course, you're going to need people to manage these things, to make sure that they are up to date with the regulations, up to date with it's actually doing what it's supposed to do, and it's not causing the biases or undue problems. You're absolutely right. And we'll always have some bias. It's a matter of how do you do that in physical world today? You do checks and balances. We're talking about implementing the same kind of thing in an agent world.
How fast can you change a system?
I can't tell you that answer because it depends upon the environment, how you implement it, and what policies.
Depends on how it was built too.
Yeah.
If you built your agent on your own data, yeah, it's gonna be quicker. If you built it on a pre-built base model, it's not gonna be quicker. It all depends on what type of model you're actually using. Is it CAN-based or are you doing a custom?
Right. Traditional thinking was we will solve all these things by rule space. That was AI about 15 years ago, maybe 20 years ago. Then people evolved and they say, no, we have to use data. Now it's all about data. Every AI is about data. And every data engineer started becoming AI engineer. So that was the thing. Now we're talking about the systems, the rules, and data together, which will make sense more in our current environment. That's what we're driving towards. Is it perfect? No, but it's a continuum.
And then you have adversarial computing.
Absolutely. This is scary in many ways from people who have started with traditional approaches, and there would be a lot of job loss. I can see that, right? People will be losing. There's not going to be as many need of people doing a lot of these administrative functions. This will move more towards agents wherever it's possible. But how do you deal with it? How do you go get ahead of it? We'll talk about that in a bit. So at this time, we are talking about the workshop. Right, so those who have your laptops, please go ahead and fire it up, assuming you have Docker. I do have microcontrollers. I have about 20 of them. Please, those who are doing this, you're welcome to take one and use it. Once you're done, you can give it back to me. Would you mind passing it around? Yes. So those are laptops. So this is a workshop stage. We are not going to be building AI agents today, but those who are inclined to try it, please feel free to do it. We will, I'm more than happy to watch if those who are interested.
What's that?
What you're going to be doing today is quite simple. What you're going to see is an ESP32 board. It's just a microcontroller. What you're going to be using is very simple serial communication. You're going to read a serial input and use this influx data. It's very simple. You don't really need to code much for this, right? We'll explain to you. If you go to the GitHub link that I have shared here, you will be able to download this file and you should be able to run it. At this time, I'm going to pause the discussion, I'm going to pause the presentation here. It's all about AI agents and things that are scary or sounds interesting in the borderline of all these things, right? Fundamental question you should ask yourself is, whatever kind of job you're doing, all right, how much of it can be done by a machine, or should you even worry about it? My takeaway is just these 3 points I'm trying to make. Number one, yes, there would be a lot of changes in next 3-4 years. In next 1 or 2 years, people are going to experiment with it. There would be a lot of failures, but after that, some of this work will be done by machines. Right? This bottom line is, there is no need to be afraid. Instead, try to learn about it and get ahead of it. That is my core message of this whole presentation. And thank you very much. You've been a wonderful host. And despite all the technical challenges, I believe you guys learned something out of today's discussions. Thank you very much.